Hoarding now. Okay, this is the second half of quadratic functions. First half we talked about vertex forms. So h and k are like embedded in the equation. It has parentheses here. H and k tell you where your vertex is located. Make sure that when you are looking at this equation, the h, you use the opposite sign, and the k, you use the same sign, and that will tell you where your vertex is located. We took all these notes on Friday, and that video I will post with this one on Google Classroom. So if you missed it, you can find it on Google Classroom. Okay, now the next one is polynomial form, which I do not call polynomial form. I call it standard form, because every other book besides this one will call it standard form. Okay, your book will call it polynomial form, but the other ones call it standard form. Okay, standard form is ax squared plus bx plus c. That's like the main quadratic function standard form. Blah blah blah. Okay, when you're trying to find the vertex, you use negative b over 2a. Now, do you guys know where negative b over 2a comes from?
Yeah.
Yeah, the quadratic formula. If you look at the quadratic formula, negative b over 2a is right here. That is not a coincidence. There's a special reason for that, okay? So to find the vertex, to find the x-coordinate of the vertex, you do negative b over 2a. And then what does this crap right here mean? F of negative b over 2a. I don't know. Okay, that means plug this in to find the y-coordinate. So whatever you get for the negative b over 2a, you plug it into the equation and find the y-coordinate, and then you're done. Okay, and that will give you the vertex. So they want us to do that for this function right here, x squared plus 2x plus 3. So we first need to find negative b over 2a. What is b in that equation? 2. So we do negative 2 over 2 times a is 1. Negative 2 over 2 times 1 is negative 1. So that's my x-coordinate. Now to plug in to find the y-coordinate, I'm going to do negative 1 squared plus 2 times negative 1 plus 3. Tell me in a minute. Okay. All right, negative 1 squared. My algebra kids screw this up all the time. Make sure that you put it in parentheses. Negative 1 squared is positive 1 minus 2 plus 3. What's that? What? Is it 2? 2. So my y-coordinate is 2. Negative 1, 2. Right there. And then they want us to find the x and y intercepts. Okay? To find the x-intercept, you plug 0 in for y. To find the y-intercept, you plug 0 in for x. I'm going to find the y first because it's the easiest one. If I plug 0 in for all of the places where x is, the y-intercept is 3. The y-intercept is 3. Okay? Now the x-intercept, if I'm plugging 0 in for y, you guys should kind of see maybe that this is not going to work. You see maybe yet that this is not going to work? I want to try to break this guy down. There's nothing that I can multiply together to give me 3, but when I add them, give me positive 2. Not positive and positive, right? I can do 3 and negative 1, but that will give me a negative 3 when I multiply, and that's not going to work. So if we do the quadratic formula, let's just look at this guy right here. The square root of b squared minus 4ac. Let's just look at him, okay? b is 2, so 2 squared minus 4 times a is 1 times c is 3. That would be 4 minus 12, or negative 8. We have a negative inside of the square root, which means what?
Bad.
Bad, which means what?
Not a real number.
It's not a real number, which means what?
It's an I.
It's an I, which means what?
It's negative inside the square root.
It's a negative inside the square root, which means what?
Circle. Bad.
No solutions, which means what?
There is no x-intercept.
There is no x-intercept. Yes, he's not going to cross the x-axis, and you can kind of see that by this parabola here. He's not going to cross the x-intercept, or he's not going to have an x-intercept. Okay, we can do that by, what was this guy called again? So it's the discriminant, and really the discriminant is everything except the square root, but I just left the square root in there so you could see that, oh, square root of a negative, not good. Okay, so there is that. All right, okay. That is standard form, polynomial form. Okay, the next one is x-intercept form, which I call it factored form. Factored form, he's already factored down basically, okay? To find the vertex of the factored form, you take the two factors, add them together, and divide by 2. It's like averaging the two factors, or the two zeros, basically, okay? Because if you think about this, if I have a 0 located at 2 and I have a 0 located at -2, and I'm trying to find the x-coordinate of my vertex, he's probably going to be somewhere here or here or here, but his x-coordinate is going to be 0, something, right? Because if I average 2 and -2 together, it's going to be 0. It's going to be halfway in between those two. So that's basically what they're wanting you to do, is the roots, or the zeros, added together divided by 2. And then you plug that back in to find the y-coordinate. Okay? All right, that's the formula. Let's go to the backside. Yeah? Backside. Backside, there's a lot. There's a lot back here. X-intercept form. For the graph of the function, so we've got this thing going on right here. Find the vertex. Okay? My zeros are those two numbers. Okay? If I set x minus 4 equal to 0, what's x equal to? 4. And if I set x plus 2 equal to 0, x is equal to? -2. Now, that is helping me find my x-intercepts, right? So 4 and -2, okay? So basically, I'm going to have a parabola that's either like a U-shape, a frowny face, or a U-shaped smiley face, okay? And the x-coordinate of my vertex is going to live halfway between there. It's 4 plus a -2 divided by 2. It's basically finding the midpoint. What's halfway between 4 and -2? 1. So this has to live somewhere on 1. I'm going to go ahead and put a dotted line here because that's actually an axis of symmetry at 1. So I know my my vertex has to be located at 1, something. And how do I figure out what this something is? Just like I did on the last one. Plug it in. -1/2 times 1 minus 4 times 1 plus 2. Okay, -1/2 times -3 times +3. Ew, yuck. 3 times 3 is 9. 9 times 1/2 is 9/2. Is it going to be a positive 9/2 or a negative 9/2? Positive. I know you're not paying attention. Which is 4.5. So 1, 4.5, that is where our vertex is, and he looks like this. That is him, okay? But the formula for finding the vertex is the s plus t over 2, or basically these roots. That plus that divided by 2, and then just plug in. Okay, that's that formula for finding that vertex. Okay? So it just depends on what format it is in. If it's in standard form, it's -b over 2a, and then plug in. If it's if it's in x-intercept form, or if it's in factored form, you go ahead and take the factors and divide by 2. Okay, does that make sense that you would like average those two factors together to find that middle? Right, if one's at -2, one's at 4, your vertex has to be halfway between those two, otherwise it's not going to be in the middle, right? Okay, good? All right, I don't know how much of this I'm going to make you do for example 4, because we skipped a lot of this last year because it's kind of meaningless, okay? But I'll talk about it here just real quick. Changing to polynomial and x-intercept form, okay? So basically like taking each one of these and they want you to write it in a different form, okay, is what they're having you do, right? Let's just go ahead and label what each one of these is in. So what form is A in? What form is part A in? Which one of those forms is he in? He is in vertex form. They call it something else. What do they call it? Do they call it vertex form? Transformation. I don't like that. Vertex form. What's part B in? Standard form? Okay, and C is in factored form. Okay, so here's what I'm going to do. Anytime they have you switch from one form to the next, okay, only switch it to standard form. Whatever form they're asking you to put it in, just worry about switching it to standard form. Do that on your homework assignment also. Just worry about switching it to standard form. So part B is already in standard form. We don't have to do anything with him. He is done. He's already in standard form. But how do I go about switching this guy to standard form? Like part A. How do I go about switching part A to standard form? What? What do I have to do to part A to switch him to standard form? What? Foil. I have to foil. This guy right here is x minus 3 times x minus 3. I'm going to have to FOIL him out, okay? So I've still got that 0.4 in the front, and let's just write out what he looks like when he's FOILed, and then I have plus 2 on the end, okay? We're going to FOIL, and we're going to put our FOIL piece inside of those parentheses, okay? All right, FOIL. X minus 3 times x minus 3. X times x is x squared, okay? X times negative 3, negative 3x. Am I going too fast? Negative 3 times x is another negative 3x, and then I have plus 9. All right, I'm going to go ahead and make that minus 6x in the middle there. So I've got that. And then there's one more thing two more things that I really have to do. What do you do next? Distribute the 0.4. Is that what you said? Yes. Distribute the 0.4. So 0.4x squared. Oh boy. Minus, what's 6 times 0.4? 2.4? Check me. 0.4 times 6? 2.4 minus 2.4x. And then 9 times 0.4 is 3.6. Check me. Plus 2. And then all I have to do is put those two pieces together. The 3.6 plus the 2. So 0.4x squared minus 2.4x and then plus 5.6. Okay? Now, the reason why I'm having you put that into polynomial form is because polynomial form above any other form is the one that I don't forget. The negative b over 2a is how you find the vertex for that one. If I forget how to find the vertex in any of the other forms, just move it to polynomial form and do negative b over 2a, right? If they give you something that looks like a, and you're like, oh crap, I don't remember what the vertex was, just do negative b over 2a, or just switch it to polynomial form, this one right here, and do negative b over 2a and find your vertex, okay? C. How do we find C? Or how do we switch C to polynomial form or standard form? What? FOIL again. Yep. So this piece right here we have to FOIL. And then we're going to distribute the negative 2. So x squared plus 2x minus 4x minus 8. Yeah? After you FOIL. Was that too fast? No? Good? Okay. I'm going to put these middle two pieces together, which makes something. 2x minus 4x. Negative 2x. And then let's distribute the negative 2. So he will be, I hear Macy Pro back there. Negative 2x squared plus 4x plus 16. Easy. Boom. Done. Okay. So anytime they ask you to like switch something to another form, just switch them all to standard form. Okay. Switching everything to like vertex form involves like completing the square and some other weird funky things. And we're not going to do that because I don't really see the point of it. Okay. Changing to transformation form, we're going to skip that part, but we're going to go down here to the summary because he is important. Okay. This basically tells you all of the information packed into one little place. So when you start to do your homework assignment, they ask you for different things. Refer to this box. Okay, refer to this box. Okay, now, when you're finding the x-intercepts of something that is in polynomial form, they only give you negative b, they only give you the quadratic formula. But keep in mind that if you're in standard form and you can factor, that's easier, right? If you can factor something down and break it down into two separate pieces, that's easier. Like, for example, x squared plus 5x plus 6. You're going to break that down into x plus 2x plus 3. Rather than doing the quadratic, this is easier, okay? So, this box, they only tell you to do the quadratic formula, but keep in mind that you can do the you can factor it down as well, okay? But this basically has all of your stuff in it, okay? Good? Let's see what the rest of this is. Find the dimensions of a rectangular field that can be enclosed with 3,000 feet of fence and has the largest possible area. Largest possible area. Maximum area for a fixed perimeter. Okay, so 3,000 feet of fence. What is that referring to? It's not area.
Perimeter.
Perimeter. Okay, perimeter. So how do I find the perimeter of this guy? It's already labeled. Two x plus 2y equals that 3,000. Okay. Now we're going to use the equation for area. They want the largest possible area. So I'm going to say large area equals x times y, basically, is what we have going on there. Large area equals x times y. Okay, now what? Let's solve for x in the top equation. 2x equals 3,000 minus 2y. And then divide by 2. X equals 1,500 minus y. Now I'm going to plug that in here. 1,500 minus y times another y. Okay, a little off. Very good. 1,500 minus y, plug it in for x. Okay? All right, that is going to give me, and I'm going to write it in order, negative y squared plus 1,500y. Yeah? This is the equation that I have. Okay? When I'm trying to find maximum, think about graphically what that will look like. Think about graphically what the equation negative y squared plus 1,500y looks like. He's a parabola, right? What kind of parabola? What? Negative. Down. He's going to look like this. If I'm trying to find the maximum, basically I'm trying to find this guy. What is that? The vertex. Basically, it's like saying find the vertex of this equation. Okay? Well, he's kind of in standard form now. To find the vertex of the polynomial form, you do negative b over 2a. Negative b over 2a. Okay? So 1,500 is my b. What's a? Negative 1. So negative 1,500 divided by 2 is 750. Is that right? Yeah? 750? Okay, and that's equal to y, because I just solved for y. Okay? 750 equals y. That's what I want. Okay? Now, let's plug back into like this top one here, and we'll get what x is. Okay? I'm going to run out of room. 2x plus 2 times 750 equals 3,000. 2 times 750 is 1,500, and 2x equals also 1,500. If I subtract over, what's x going to be? Did you hear me say the other day when we talk about perimeter, when we are trying to minimize perimeter but maximize area, your rectangle is going to be as square as possible? Is my rectangle a square? Yes, 750 by 750, okay? When you're minimizing perimeter and maximizing area, you want your rectangle to be as square as possible. Those are the dimensions that will make it that way, okay? Should we do example 7 or should we skip? Skip? Let's skip. Okay, it's going to be another maximize one. So whenever you're trying to maximize, whenever they say this word or minimize, they're basically saying find the vertex. Find the vertex. But they don't say it that way. They say find the maximum and minimum. Find the vertex. Okay? Good? That is all. I wonder if Cassidy like thinks that I'm shouting into this computer screen. I'm sure.